Today we finally get to do a lab, and this lab is called Where Will the Vehicle Be? So in studying motion, only two quantities can be easily measured, position and time. All other quantities related to motion are calculated using position and time measurements. One such quantity is called speed. Speed is the rate of change of position over time. It is a tool that scientists can use to make predictions about the motion of an object, such as the time required to travel a given distance or the distance of travel that can be achieved in a given amount of time. To determine the average speed of an object, measure the change in position, which is the displacement, delta x, for a time interval, delta t, and divide the displacement by the time interval. So the velocity is equal to delta x over delta t. If an object has a uniform displacement over equal time intervals, the value of the average speed is constant. The slope of plot of position versus time is a straight line. The slope of the plot of position versus time, I typed that twice. The slope of a line is the ratio of rise to run. So in this case, the rise is equal to the difference. So V is equal to delta x over delta t, which is xf minus xi over tf minus ti. So anyway, in this lab, you will study an object moving at a constant speed. You will record the time it takes to move over given time intervals and make a graph of the motion of the vehicle. You will calculate the velocity of the vehicle and analyze the results. So you have a constant speed vehicle, a meter stick, and a stopwatch. So what you're going to do is, I need to demonstrate. And they're too big to put under here. All right, I'll think of something. So let's look at the directions. It says set up a meter stick lying flat on the table so you can read the values in centimeters. Now you're going to be using a meter stick, but I'm just going to show you with a ruler. Then it says to obtain the first measurement, one student starts the vehicle. So you turn it on, and then someone else has a stopwatch. And what you're going to do is you're not going to put the car at 0. And the reason is because because of human error and how long it takes you to press the stopwatch, you're not going to be able to press it when it already starts. So you're going to move the car back behind the meter stick. And then when the vehicle goes in front of 0, you're going to press start. And then when it goes to 10, you're going to press stop. Then you're going to repeat the same thing, and you're going to go start to 20, start to 30. Okay, and then you're going to record all of this here in your data. So this is the time it takes to go from 0 to 10, 0 to 20, 0 to 30, 0 to 40. Then this says the time for every 10 centimeters. So what you're going to do is you're going to divide by the numbers here. So this should actually all be the same amount of time. Then you're going to draw a position versus time graph. So what you're going to do is you're going to have your position versus time. You need to label your axes. And then what you're going to do is you're going to include your units. Calculate the speed of the vehicle. So that means you need to write your given. You need to write your basic equation. You're going to rearrange the equation to solve for the unknown in terms of the known, and you're going to substitute and you're going to solve. And then you're going to answer all these questions in complete sentences. What would be the possible errors? We don't write human error. We have to be extremely specific. And that's it. So this is a pretty easy lab to do. And then when you're done, you're going to turn in this lab sheet. And that's it.